So choice of right statistical test. So this is the which test to use when. What is the statistical test of choice for you? That is the question. Okay. I have appeal one. First appeal will make you happy. That is, statistics is a very vast subject. You cannot know everything from statistics. First. So you should not hesitate to say, I don't know this thing in statistics. Be bold to say, I don't know in statistics. But at the same time, when you come across something in statistics, refer the books, ask your friend, refer internet, then get to know what you are doing. The internet now broken everything, every barrier. That is appeal number one. You should understand statistics, vast subject, you cannot know everything. Second appeal is this one. This is called golden circle. That is the questions why, what and how. Why and how are the most important questions where science you should ask why and how, then only you are a great thinker. This question stand above all the questions. But don't worry, I am asking your brains to take rest. Don't ask how and why. Why we are doing this test here? No, we are not going to ask the question. How we are going to do this test? No, we are not going to ask those questions. What is the test going to be applied under certain circumstances? That is the only question we are going to. So here you should understand I am repeating my word. What is the statistical test under certain circumstances? Here, circumstances are more important than what is the statistical test. You should be clear about the circumstances. In real life also, circumstances matters more than any other things. So that has a value. So these are my two appeals. With this I am going to the class. Why this class is very important is, first there are different kind of researchers. One is if you are a community medicine PG, other PGs, or if you are non-community medicine PG, you will go and ask other PGs that you need a significant p-value. You always ask for, sir, I need a significant p-value. They don't know what is the meaning of it. But otherwise, the second level they will ask, they are little matured enough to ask, sir, I need some p-value from this study. Then the third group will say, I need p-value, but I don't know what test to apply. And fourth level is, I have p-value using this statistical method. And I assume that by now you are in the third level, that I need p-value for my study. I don't know what test to apply. So I am here to help you to make it to the fourth level. I have p-value using this statistical method. I am trying to keep everything very simple. I am not going to too many details. This is the 5 steps in calculating our statistical test. First is, what is your hypothesis? By now I think you all are very familiar with these terms. What is your hypothesis? Second is, are the sample independent of each other? The opposite of independent is paired. Don't worry, I am using some complicated terms. Ma'am is shaking her eyes. These are the next 5 slides, and this is my entire presentation. Okay, I am going to divide these lines and I am going to make the presentation. And what are the types of variables? You all know nominal, ordinal, interval, ratio. That is again into categorical and continuous variables. Now, are they distributed normally? That is the fourth one. Fifth one, apply this test, find the p-value. Okay, this is the 5 steps. So, what is your hypothesis in this thing? First thing, I am going to the hypothesis. First of all, you should know the hypothesis. We were all trying trying to explain what is alpha error and beta error. You can see this image, and you can find one more example for alpha error and beta error. This is a false positive, and false negative will be called as type 1 and type 2 error. Hypothesis. Why your hypothesis is important? Hypo means what? Hypo means what? Below. Epi is over, upon, among. Hypo is below. It is just below your thesis. Your hypothesis is placed just below your thesis. It is so important to know what is your hypothesis. That is almost equal to knowing your thesis. So you should frame your hypothesis properly. There are two hypotheses which is mainly important. One is null hypothesis, the other one is alternate hypothesis. Who is null hypothesis here? You can imagine your gate as a null hypothesis. Whenever you say, sir, there will be difference in stress level among first years and second years, sir. Hey man, no, there won't be any effect. What difference it will make stress levels among first year and second year? No. That no is the null hypothesis. So you try to disprove that gate. No sir, you are wrong. No, you are wrong. So that is your ultimate objective of the study. You try to disprove the null hypothesis. That is, no difference are equal. First year and second year has same stress level. That is the null hypothesis. You are trying to disprove that, and your hypothesis is your alternate hypothesis, or otherwise called as research hypothesis. That it says that there is difference and they are not equal. You are going to decide whether the sample is independent of each other. Okay, so you are going to compare between men and women, or you can see the image here. You are going to see men and women, or women and men before marriage and after marriage. So you have to decide what you are going to do. That is the second step. So when your sample are independent of each other, when males are compared with females, you have a different set of tests. When males are compared before and after marriage, in the same example of first year and second year stress levels, you calculate stress level at admission, and after passing their first year 1 year later, then that will become a paired sample. But if you go today, ask your first year and second year simultaneously, then that is called as independent observation. Understood? Independent and paired are clear. Now, other examples are all your pre-test and post-test, before and after intervention. All these are all pre. So now we have completed the second step. Third step is what type of variable it is. Usually in statistics we used to say nominal, ordinal, interval and ratio. Club this nominal and ordinal to categorical, interval and ratio to continuous. It is as simple as that. Club those into categorical and continuous. So and one more thing you should be clear, what is your dependent variable and what is your independent variable. Independent variable is your first year of study. Dependent variable is stress level. You cannot say because their stress level decides whether they are in first year or second year. That is not possible. So you should choose what is dependent variable and independent variable. If suppose I study sleep in the same study, sleep, stress and year of study, sleep and stress, this independent variable and dependent variable may interchange. Because of sleep, stress may change. Because of stress, sleep may change. These things will happen. But during analysis, you should be clear about what is dependent analysis, what is dependent variable, and what is independent variable. Otherwise, these variables are otherwise called as predictor variable and outcome variable. Your stress level is the outcome variable, year of study is the predictor variable. This you should be clear which is causing which. Not like the chicken and egg story. Okay, so now we are clear about the third step. Type of variable also is first. What is your? We were clear about hypothesis. Then paired or independent observation. Then type of variable, continuous or categorical. Again, dependent or independent variable. That you should be clear. Then fourth. Now I think by now you all have got clear about what is normality. Why this normality is important? Because all these distributions are so important, because from your sample you are going to predict something for the, recommend something for the general population. Okay? So that is why you need to apply this test for normality. If the data is normally distributed, then you say you have to apply parametric test. Then if the data is not normally distributed, then non-parametric test. As simple as that. Okay, now fourth point. This fourth point takes some 2 or 3 slides. I will explain in detail. I think it will be a repetition. You can revise, you can recheck whatever the data. Why normal distribution? Because we need to apply parametric test. That is why we are checking for normal distribution. Why parametric test? Because parametric tests are stronger than other tests. That's all. If the variable is normally distributed for the sample population, then the statistical conclusion made for the whole population will be more valid. When the data is normally distributed, if you make conclusions for the general population, then your data will be, then your study conclusion will be more accurate and more valid. That is why we are always running behind this normal distribution. Whenever a data is normally distributed, the conclusion for the general population is so strong. So now reasons for non-normality. Why you are getting a sometimes when during analysis, oh, I have got a non-normal data or a skewed data. I think since I have manipulated the data, I have been caught red and no, it's not that way. There are certain variations where you get certain circumstances, naturally you get skewed data or non-normal data. Presence of outliers. In every situation there will be outliers. For example, if you plot the income of India, there will be Ambani and Adani, who always pull the income of the average income of the country towards right side. Most of the people will be in the lower and middle income. So you can't help it. That is the nature of India. So it is not normally distributed. Your income is not normally distributed. There are outliers. And many times non-normality, the cause is low sample size. Most commonly when the sample is less than 30, you land up in non-normal distribution. So that is also very important. So that is why we say, if you don't calculate sample size also, just do at least 30 samples, then only we can do some parametric test. Then your conclusions will be more strong. That is why we always run behind this 30 sample. As I said, nature of the data itself will be, we all know Hodgkin's lymphoma has bimodal distribution. You cannot expect a normal distribution for age. If you take Hodgkin's lymphoma patient's age, it shows a bimodal distribution. If you expect normal distribution, you are not going to get it. So that's how the nature of data itself will not have a normal distribution. Now we are clear about, we know the importance of normal distribution. Now how to check for normality? There are certain tests in SPSS. Don't worry about these tests, how I am going to do. These are all with a single click. Matter of clicks you can do this. So these two tests are called Shapiro-Wilkoff or Kolmogorov-Smirnov. KS test or SW test we say. Shapiro-Wilkoff is for sample size less than 50. Kolmogorov-Smirnov is for sample size more than 50. That's all. So this thing. But we have a problem with this thing. When the samples are less than 20, they are too liberal. When the samples are more than 50, these tests are more sensitive. When the sample size is large. So you need not rely on this test so much. You can just draw histograms and a normal curve. If the curve resembles well-shaped curve, then you can conclude it is normally distributed. That is the best way. Human eyes are better than all these tests for normality. KS Shapiro-Wilkoff and KS test. So that is how we are concluding with the normality. That is for the bell-shaped curve. No sir, I will not do that. For various reasons, I will not do that. I will not do your bell-shaped curve similarity assumption. I need some other thing. Then here is your answer. If mean, median, mode are almost closer and standard deviation is less than half of your mean, or mean is more than 2 standard deviation, then you can conclude that age is normally distributed. Okay, that's all. So this is the fourth important step. The data is normally distributed or not. Fourth important step in normally distributed. Why we are running behind normality? We need to do parametric tests. Parametric tests are more stronger. then when I need to extrapolate it for the general population, I need to give stronger results. So that is why we are doing. How we are finding this normal distribution, Ks test and Shapiro-Wilcox test. Okay, before, if it is not normal distributed, don't take a U-turn to non-parametric test. Try one more time for transforming the data. As he said in Professor Research class, it was there were two different things. But here I am just mentioning there are logarithmic, square root and inverse transformation. These are the commonly used transformations. So transform this data. Sometimes this data may be normally distributed. Then you can apply parametric test. Then you can control it for the general population. Now we are going to the choice of. So now we are clear about the circumstances around the statistical test. So what is the choice of statistical test? This is the next two slides is going to be the very important slides. This table. If you are clear about this table, the class is over. Okay, and if you understand what it is, so now can we apply what we are doing? Whenever I say one variable, you just murmur one example for it. When the outcome variable is continuous, for example BP, if this is my outcome variable, if it is continuous, suppose blood pressure is my outcome variable, I am going to compare it with the exposure variable or the predictor variable for two groups, male and female. Is there a difference between male and female blood pressure? Then, and the data is not normally distributed, then I need to use two sample t-test or independent t-test. And if the data is not normally distributed or skewed, then you need to use Mann-Whitney U-test. If the data is paired, suppose it is a BP before intervention of the drug, after intervention of the drug, and the data is not normally distributed, then you need to use paired t-test and it skewed Wilcoxon signed rank test. More than two groups, suppose for example rural, semi-urban and urban, those kind of groups are something else, then you need to use one-way ANOVA, and the counterpart for skewed data is Kruskal-Wallis test. If you are comparing BP with directly age, then and the data is normally distributed, you need to use Pearson's correlation or linear regression. And if the data is skewed, you need to use Spearman's correlation or linear regression. No need to bypass all these things. This is just the table. You can download in your, you can have it in your mobile. I will give this presentation. Anytime you can see this, and there are better classification than this. And there are various ways also. Just understand the logic behind it. Begin the decision of the statistical test. Now categorical. Categorical means say hypertension present or absent for male and female. Then you need to use chi-square test or Fisher's exact test or logistic regression. Fisher's exact test is the test we use when the cell expected value are less than 5. Cell expected value is less than 5, then we use Fisher's exact test. Okay, we will deal with it in example. You are going to answer. Then logistic regression. Regression is just for prediction of one variable by other variable. I will explain that also later. Then paired. Hypertension present or absent as a category. Then before drug and after drug, then you need to use McNemar's test. Kappa statistics is also similar thing. I will explain to it later. Greater than two groups, again the chi-square, Fisher's exact test, logistic regression. Category hypertension present or not, age is your continuous variable, means logistic regression, sensitivity, specificity, ROC. Okay. Can we answer with this? Okay. The more detailed thing for the paired variables, that is McNemar's test for, this is a variable, category before and after. Paired variable before and after means McNemar. Paired variable more than two. Suppose you want to see between three groups before and after, Cochrane Q, ordinal Wilcoxon signed rank, quantitative Wilcoxon signed rank, parity test. Suppose you are doing, I have said before and after. Sometimes you may need 1 month, 2 months, 3 months, 4 months like that. BP, effect of the drug BP, then you need to use repeated measures ANOVA. And if it is the outcome variable as categorical, then you need to do Friedman test. Okay, this is what simple thing. From this, based on this, I have given